Guessing we should do a little bit of review since we've been gone for 11 days.
Probably.
So I want to start with just naming our function. So let's say we have a triangle here, and I'm going to label it A, B, and C like this. And I'm going to call the side, somebody give me a number between 5 and 15.
7.
7 works for me. This will be 7, 24, and 25. So we have this triangle, obviously not drawn to scale. If I ask you, what is the sine of angle A? Sine is what two sides? Careful. Opposite hypotenuse. So according to angle A, what is the opposite side? 24. Of course, the hypotenuse always be the 25. This is going to be 24 over 25. The cosine of angle A. Cosine is what two sides? Adjacent over hypotenuse. And according to side A, the adjacent side would be that one, right? So it would be 7 over 25. Tangent angle A. Well, tangent is opposite over adjacent. So for this triangle, angle A, tangent would be 24 over 7. Otherwise known as 3.42857. Cotangent of A. Cotangent is just the reciprocal of tangent. 7 over 24. Or cotangent is adjacent over opposite, which would be 7 over 20. Secant of angle A. Got it. Hypotenuse over adjacent. 25 over 7. 3.571. Cosecant of angle A. Hypotenuse over opposite, or 25 over 4. How about the sine of angle B? Well, sine is opposite over hypotenuse, right?
Yeah.
The angle B, which is the opposite side. 7 is now the opposite side. So the sine of B would be 7 over 25. Notice that's the same as the cosine of A, because those are complementary angles. How about the cosine of B? Got it. The 24 would be the adjacent side now, so it's 24 over 25. Notice that is the sine of A. The cosine of one is the sine of the other, and the sine of one is the cosine of the other. Tangent of B. Over 24. Cotangent of B would be secant of B. Perfect. And of B has to equal the cosecant of A. The secant is the one is the cosecant of the other, right? And of B, 5/7. And cosecant of 1 equals the secant of the other. We know that we can find the value of many of our trig functions from other trig functions. You ever get those down in your person? One, tangent of an angle is the opposite over the adjacent sides. And we saw that you can actually find that by doing sine of the angle divided by the cosine of the angle. Because the sine is opposite over hypotenuse, and the cosine is adjacent over hypotenuse. The hypotenuse divides out there, leaving us opposite over adjacent. So if I want to find the tangent of an angle, it's the sine over the cosine. Likewise, if I want to find the cotangent of an angle, cotangent is the reciprocal of the tangent, right? Which means you do what to the fraction? Over. Cosine of that angle divided by the sine of that angle. Those are ones we've seen, but we really haven't talked about them a lot. The ones that we have used extensively is the secant of the angle, the reciprocal of cosine. For those are the ones that are backwards. Tangent and cotangent are reciprocals, but it's secant and cosine. And of course, the cosecant is the reciprocal of the well, there's one more identity that I want to look at. From the unit circle. Pretend that's a circle. What's the length of that little brown line I just drew in? 1, because the unit circle has a radius of 1. This is my angle here. I'll just call it angle A. This length is the sine of A. This length here, cosine of A. And of course, this is a right angle there, because the sine is always measured perpendicular to that horizontal diameter, that reference diameter. Well, in a right triangle, we have a relationship between the length of the sides and the length of the hypotenuse. Right? Well, the legs here are the sine leg A, the cosine leg B, and of course 1 is the hypotenuse. So A squared is really sine. B squared is really cosine of the angle. Equals the hypotenuse is 1. What's 1 squared? 1. There we go. But this information I just put out here, if I tell you that the sine of angle L, 0.8, he can find all the other trig functions. I ask you to find the cosine of angle M. Use this right here. Sine of angle M is 0.8. It's going to be that squared, right? Plus, the cosine is what we're trying to find. That squared. 1. What's 0.8 squared? Oh, you're thinking times 2. The right idea, 0.64. Now we're going to solve that for the cosine of M. What's the first thing we should do? Subtract the 0.64. That gives us the cosine of M squared equals 1 minus 0.64 is 0.36. How do I solve for the cosine of M? How do I get rid of the squared? Root. The root of 0.36 is 0.6. Cosine of M, 0.6. If the sine of M is 0.8. That's the hard part. The rest of it is pretty easy. How do I find the tangent of angle M? Perfect. It's sine over cosine. 0.8 over 0.6. I could just leave it at that, or I could divide it out to be 1.33, either one. Cotangent of M. Perfect. 0.6 over 0.8, or I could divide it out to be 0.75 if I want to. Either form is acceptable there. Probably the fraction is probably easier to work with because you can see where the numbers came from. Got it. It's 1 over the cosine, so it's 1 over 0.6. Again, you could leave it like that, or you could divide it to be 1.67. Cosecant of M? Sine, so it's 1 over 0.8. Again, you could leave it as 1 over 0.8 or change it to 1.2. There's numbers, calculations with numbers is all about pattern. And once you start to see the patterns, the calculations are pretty easy. I'm like the dividing by 7 up there. That takes a distinct pattern. So that's why I could do 24 over 7 is 3.4, 2857143.
Okay.
He has it all memorized.
I know what kind of joke you're on, but
1/7 is 0.42857.
what's that movie where that girl unlocks like 100% of her brain? Yeah, give me some of that. PHP, wherever that is, PCP.
PCP. Once you start to see the patterns, the calculation makes it real.
Well, the 0.8 kind of makes sense because isn't it like
5 over 4.
yeah, 1/8 is 0.125?
So there, just from giving you the Sine was 0.8. We found the cosine, the tangent, cotangent, secant, and cosecant. What if I tell you that A plus B? What is that telling me about those angles?
Complementary.
They're complementary. Very good. If I tell you the sine of angle A, 0.8, and the cosine of angle A, 0.6. These are just the same numbers as we had in that last example. What if I ask you to find the sine of angle B? Since A plus B equals 90 degrees, those are complementary angles. The sine of one is the cosine of the other. Cosine of A is 0.6. So the sine of B is just 0.6 because cosine of A is 0.6. Oh. Cosine of B, these two, if I square them, will add up to 1. 0.8 squared is 0.64, 0.6 squared is 0.36, that adds up. Cosine of B. Sine of A, right? Okay. Once we know that, what if I ask you to find the tangent of B? Back to what we were doing before, 0.8 over 0.6. Just sine of B over cosine of B. Backwards. 0.6 over 0.8. Sine of B is 0.6. Cosine of B is 0.8. 0.6 over 0.8. 0.75 if you want to divide them out. Cotangent of B. Cosine over sine, right? That one's 0.8 over 0.6. That's the 1.33. How about the secant of B? One over the cosine, so 1 over 0.8. You got it. 5. Cosecant of B? One over the sine of B? 1 over 6. 1 over 0.6, yep. 7 if you want to divide it out. You haven't done yet?
Well, I'm just worried about what's coming next.
I'm sensing a lack of trust.
Well, you said that was review, right?
Yeah. We got a little more review to go yet.
I'm more of a review kind of guy. I'm not. But
We were talking about the Theodolus, right? Set up a job site. Here's what we're going to do. We're going to have a reference line. I call this 0 degrees. This is actually the edge of the sidewalk. We know this is our Theodolus right here. first corner of the house, from that location, we want it to be 13 feet away from the Theophilus at an angle of 22.62 degrees. This angle is 22.62 degrees, 13 feet. I want to know how far it is direction, call that X, direction, call that Y. In other words, now how would I find X here? Well, according to my angle here, the 22.62, X is which side of that right triangle? It is the leg that touches that angle. 13 is which side of the right triangle? It is the hypotenuse. It is across from the right angle. So to find the X, we are dealing with the hypotenuse and the adjacent. What trig function is that? Secant, but also cosine. Now I usually write out the definition just to keep from making a mistake. Cosine of the angle is adjacent over hypotenuse. I have my angle is 22.62 degrees equals X over 13. And to solve this, if I am looking for a missing side, I put my trig function over 1, so it's a proportion, and I cross multiply. So I'm just going to do cosine of 22.62 times 13 divided by 1. Cosine 22.62. Make sure you close the parentheses. Times 13, and you don't have to divide it by 1 because it doesn't do anything. You get 11.9999999, otherwise known as 12 feet. That's 12 feet there. For Y, I want to find side Y. Y is what side according to this angle? Opposite side. And I'm going to go back to my 13 for my hypotenuse. What trig function is opposite hypotenuse? Sine. So the sine of the angle is the opposite side over the hypotenuse. So we plug in sine of 22.62 degrees equals the opposite side is going to be Y over my hypotenuse of 13. Once again, I put my trig function over 1 and I'll cross multiply and divide. Cross multiply and divide, I get like, what, 5.0000 or 4.9999?
Yeah, I got a calculator in my head.
5.00028. Yeah. That one I kind of cheated. 5, 12, 13 is a common right triangle.
Sorry, I thought.
That one I knew, but I didn't calculate. So we've located that first corner of our building. Let's say our building now is going to be 40 feet by 28 feet. If I want to locate this corner right here, call this corner B. Triangle I'm looking at, this triangle here. I'm going to redraw it over here. What do I know about the length of this side up here? 40 feet, 12 feet, right?
The building was,
The building here is 40 feet, that means this has to be 40 feet.
was in the triangle.
Yep, that's why we had to add the 12 feet there.
Oh,
12 feet from the other triangle just gets added to the 40 feet.
gotcha.
What do we know about this distance here? 5 feet, you got it. I want to know this length and this angle. The length is easy. How do I find the length?
I say.
You got it. Square root of 52 squared plus 5 squared. $52.240 feet. For the angle, looking at this angle right here, called theta, 52 feet is which side of that triangle? Careful, the 52.24 is the hypotenuse. This 52 up
I
here.
thought that's what you said, sorry.
Sorry, yep, that would be the adjacent side. I don't want to use the 52.24 because I just calculated that and I know it's rounded. So I try not to use that rounded answer if I can because it's going to throw anything I calculate from it. It's going to fall off by that rounding. The 5 feet over here is which side according to that angle? It's the opposite. Adjacent and opposite make cotangent, but also regular tangent. Tangent of our angle, and I don't know the angle, but I do know the opposite side is 5 and the adjacent side is 52. Here, I am looking for the angle. The other ones we've done so far, we were looking for the side, so we put the trig function over 1 and we cross multiplied and divided. When we are looking for the angle, we do the first trig function. First tangent of 5 over 50. Second tangent of 5 divided by 52, 5.49. The corner B here is going to be labeled 2.240 feet at 5.4 degrees. What if I call this here corner C? If I look at my little corner C there, I'm looking at this triangle here. Big one, yep. That triangle, I know this side up here is still this side over here has changed though. This piece was 5, this piece is 28, so that is 30. So I need to find now on this one, this angle, side. How do I find the side? Got 52 squared plus 33 squared and square root. Give us how much? You got it, 61.587 feet. And then to find this angle, doing a tangent again. Tangent is opposite over adjacent. Which side is the opposite side?
33.
33, and the adjacent? 2. And since we are looking for the angle, we use inverse trig functions. Inverse tangent. Of 33 over 52. Giving us what? So we'll call it 32.40 degrees, right? The corner C here is going to get labeled 61.587 feet at 32.40 degrees. If we're locating it using the field list. So we'll call this corner D. I had students several years ago that were very compulsive. So I do something like this. I go, this is corner A, corner B, corner C, and I say, this is corner G, just to tick you off. It just bugged him that it wasn't A, B, C, D.
Evil.
So anyway, yeah, that's not very nice. What part of math teacher implies that I'm a nice person? So now we're going to look at this triangle for corner D. That triangle. What's this side right here have to be? Well, from before, yeah. How about this side over here? It's the same 33 we did up here. You got it. In your notes, I want you to try to find this side and this angle. Give me a minute to do it. I'll give you 42 seconds to do it.
Always finding it.
Technically, we should say it's a reference. So the length of this side, square root of 12 squared plus 33 a squared plus b squared equals, otherwise known as 35.114. Angle is going to use a tangent again. Tangent is opposite over adjacent. Side is the opposite side. And the adjacent side, 12. So the angle itself will be the inverse tangent of 33 over 12. Now 33 over 12 is more than 1, right? So this is going to be bigger than a 45-degree angle. Comes up to be 70.02 degrees. So corner D is going to be labeled 35.114 feet at 70.02 degrees. Good stuff? So this is one of the potential practical applications of the trig that you can run into, using a theodolist for job site layout. Another potential application. Let's say we have a 2x6 here, which of course is 1.5 inches by 5.5. And I want to bevel cut one end of it here. And I want to bevel cut it such that, quarter over here. My table saw or whatever I'm going to use to cut it, what angle am I going to set my saw at? Now the angle, depending on whether you're using a circular saw, skill saw, or if you're using a table saw. If you're using a circular saw, you would use this angle here, because it starts at 0 degrees and goes up from there. If you're using a table saw, most table saws, depending on the brand, a lot of them have your indicator sitting here. That's labeled 90 degrees. You're going off of 90 degrees. Either way, let's use that angle. We'll find that angle, and we'll get the setting either direction. This is the triangle we have. What is this side over here? That is 1.5 inches. This side down here is this side, which is 1/2 inch. I can write it as 0.5. Let's find this angle up here. Well, this is the hypotenuse, so I don't have the hypotenuse. I'm not going to use that at all. The 1.5 is which angle? Or which side? Adjacent side. 0.5 is the opposite. So I'm going to be using tangent here of some sort. Tangent is opposite over adjacent. So I'm going to fill it in. I don't know the tangent. Which side is the opposite? 5, and the adjacent, 1.5. So to find the angle, it's the inverse tangent, 0.5 over 1.5. .43 degrees. So if you're using a skill saw or circular saw, you're going to set it at 18.5 degrees, somewhere in there. If you're using a table saw, you want to go 18.43 degrees off of 90. 90 minus 18.43, otherwise known as 71. 70. Set it off at 71.5 or so degrees. Make sense?
Do you think they've changed it for like memory cells and stuff? Because the table cells I've used start at 0.
Some of them do start, it depends on the brand name. Some of them start at 0, some of them start at 90. Some of them have them set at 90 because that means your blade is at 90 degrees up here. Others have them set at 0 because 0 is your base location, home location. No homework today, but there's quiz 4-10 sitting out there for you on Blackboard to work on. If the stuff we did in class today makes sense, quiz 4-10 shouldn't be tough. Doesn't make sense, maybe we'll have to discuss it a little more tomorrow. If you'd like to start working on it, I'll be on